This is the screencast for section 3.2, example 4. We're going to model radioactive decay. I don't know why, but whenever I hear about or think about radioactive decay, I picture Michael J. Fox in that ridiculous yellow suit in the original Back to the Future movie. No? Okay. So suppose that the half-life, what's half-life? Half-life is, in radioactive decay, the amount of time it takes for half of the substance to decay. Half of the substance to decay, half-life. So suppose the half-life of a certain radioactive substance is 20 days, and there are 5 grams present initially. Find the time when there will be 1 gram of the substance remaining. Well, the original value was 5 grams. Now this is a half-life of the substance, so in 20 days, half of it will be gone. So I am going to lose 50%. So I'm taking away 0.5 from my 100% of the population that I have right now. Now that's going to be raised to the power of t over 20 because it's not just 1 day, it is 20 days it will take for this whole half-life to go through. So P of t equals 5 times 0.5 to the t over 20. I'm looking for specifically when there is 1 gram of substance remaining, so I'm going to have my calculator help me with that since I don't know how to solve for exponents. Otherwise I would do this by hand. It seems like pretty easy numbers, but I don't know how to solve for an exponent. I don't know how to find it. So here we go. I put in y1 my radioactive decay function, in y2 my desired grams, 1 gram of substance. I set my window to be, I think, a multiple of 20. If it takes 20 days for half of this to decay, that would get me down to 2.5. Another 20 days would get me down to 1.25 grams. So another 20 days ought to do it. I figured about 60 days. And then I left my Ymax at 8 since the initial population was 5 and it was going to decay from there. So, in my graph, I can see the intersection pretty clearly, so if I find that, looks like it's going to take about 46.44 days. The now try problem number 33 is also dealing with radioactive decay. The half-life of a certain radioactive substance is 14 days. There are 6.6 grams present initially, so I can set up my exponential decay function. P of t equals, let's see, there's initially 6.6 grams. We are the half-life of the substance, so 50% of it will be left after 14 days. Oops, 14 days. There we go. So I can put that in my calculator and find out when there will be 1 gram remaining, since again I don't know how to solve for exponents. When will there be 1 gram remaining? Well, I found the intersection to be, I actually used the same window as last time because we started out with about the same amount and we're using a half-life that has a little bit fewer days than before. I figured the same window would work, and it does. I got about 38.11 days.